This is problem 2 from practice problems for quiz 9. As I read through this problem, I'm going to extract the information that I need. So I'm going to start. In a study of memory, two groups were shown a car crash video. They were then asked questions about the crash. Group 1, which I'll refer to as sample 1, with 15 students, so here we have an N1 of 15, was asked to estimate the speed of the cars when they smashed each other. Group 2, which I'll refer to as sample 2, had also 15 students, so here we have N2 equals 15, and was asked to estimate the speed of the cars when they hit each other. So here we have the two treatments. One was asked when it smashed, the other hit. So the manipulation of words there is the two different treatments. Going on, group 1 estimated an average of m equals 40.8 miles per hour. So I'm going to write m1 equals 40.8. And their SS is 510. So SS1 equals 510. Sample 2 estimated an average speed of m equals 34. So I'm going to write this as m2 equals 34. And they had an S sum of squares of 414. Finally, calculate if there was a significant difference at an alpha level of 0.01. So my alpha is 0.01. The first thing I'm going to do is what I'm going to do in this problem is do step 2, 3, and 4. Since this does not mention hypotheses, I will not do step 1. So I'm going to go ahead and do step 2 first. And what I'm doing in step 2 is calculating alphas t and shading in the critical region. To do that, I need three things. My alpha, which we said is 0.01. We need my df total, which I'll calculate right now. And then I also need my the number of tails. And we said that for this, we're only going to use 2 tails. Now, as for my df total, the equation I can use here is df1 plus df2. To calculate each of these df's, let's start with df1. So to do that, I go to my n, which is 15, subtract 1, and I get 14. To do df2, I go again to my n2, which is 15 also, subtract 1, and I get 14. So I do 14 plus 14 gives me 28. So in this example, my df total is 28. Looking these three pieces of information in my t table, I can see that my alpha's t is plus and minus 2.763. I am now going to graph my t graph here, and I'm going to locate both of these alphas t. So my negative, I'll say, is negative 2.763, and my positive 2.763, and now I'm going to shade in critical regions here. So these are t values. Down the middle, I have a t of 0, and I said that we are always placing sample 2 right there. And so what I'm really interested in is if sample 1, my red sample, will lie somewhere here, or if it would lie somewhere here in terms of t values. The next thing I'm going to do is step 3. And step 3 involves 3 components. The first component is pooled variance. And pooled variance will be the variance of my purple t graph. The way I notate pooled variance is s squared, which stands for variance, and then put a p in there for pooled. The equation for this is a division where we're taking SS1 on top, DF1 on the bottom, and the same thing with my blue group, SS1 on top and DF1 on the bottom. Substituting in all my information here, I'm going to start with my red sample. Its SS1 is 510, its DF 1 is 14, and that's because we have an n of 15, subtract 1, and we get 14. For sample 2, we have an SS of 414, and we have also a DF of 14. So the last thing I do is just calculate this out, and I should get 33. The next thing I'm going to calculate will be my standard error. And this is going to tell me my arms of my t-graph here. And we notate this as SM1 minus M2. And the equation for that is the square root is 2p over n1 plus s2p over n2. I'm now going to replace each of those with their actual numbers. S2p is 33, so I will replace those S2p's with 33. Both ends are 15 for sample 1 and sample 2, so I'm going to replace it with 15. The next thing I'm going to do is do the divisions first. So I'll do 33 divided by 15 and 33 divided by 15. And for both of these, you should get 2.2. And so the last thing I'm going to do, or the next thing I'm going to do is 2.2 plus 2.2, and that should give me 4.4. And so the very last thing I do is take the square root of 4.4, and that is 2.1, about. So this is my arm for the t-graph. The last thing I'm going to do is calculate M1's t, and the equation for that is M1 minus M2 over the standard error of M1 minus M2. And now I'm going to substitute in M1 with 40.8, and I'm going to substitute M2 with 34. And finally, I'm going to substitute in my standard error with 2.1. And when I do the math, my t should come out to positive 3.24. So that is my M1's t. Finally, step 4 involves locating M1's t and the notation. So I'm going to locate M1's t of 3.24, and I'm going to estimate it to be right here, positive 3.24. So this is where sample 1 is higher, which makes sense because sample 1 had a higher mean than sample 2, and it does fall, in fact, in the critical region. And so finally, my notation is t equals blank p blank blank. And so what goes in here is df total, which was 28. What goes in here is the calculated t, 3.24, and I'll include the positive sign. What goes at the end is my alpha, which is 0.01. Sorry, it's running into the other. And then since this is significant, p is less than. So there is a significant difference where sample 1, the one who heard the word smashed, likely to say that the cars were going faster than the group who heard the word hit.